Hi, welcome to our presentation on Facilities Dashboard for Data-Driven Decisions for the Tacoma Public Schools. I'm Joel Oringer. I'm a project manager and business analyst who's been working on this project with my peers for the past year. And I've been working as data steward and project manager and contributing to the majority of the deliverables.
Hi, my name is Mario Villa. I'm a program manager at AWS. In this project, I contributed to creating some of the dashboards you'll see today, as well as other analysis for our client.
Hi, I'm Swarnima Kumari. I'm a data analyst. I've been an active contributor on this project, mostly working around the predictive analytics and creating some visualizations in Power BI and Tableau.
Hi, my name is Cooper Cutler. I'm a financial aid program specialist. I've been our client contact this year, as well as contributing on some of the data analysis and data stewardness. I'll be passing it back to Joel Oringer.
So, Tacoma Public Schools is one of the largest employers in Tacoma, with nearly 5,000 employees and over 30,000 students. They have to manage over 140 buildings and stadiums, fields, more than 5 million square feet of learning and administrative spaces, most of which are available for public use after the school hours. So as a data-driven district seeking innovation in their schools, they sought to leverage the power of technology to better understand their facility rental program and assess its impacts to better serve the students and the Tacoma community. The objective was to identify facility use impact and provide evidence for a business case outlining budgetary and full-time equivalent requirements needed to run and support this facility use program. Really, the goal was to maximize revenue and reduce costs to ensure that the program can be sustainable into the future and in harmony with the intended public benefits. So Tacoma Public School and UW-Tacoma's MSBA program partnered to find solutions and analytical insights to improve the visibility into their facility rental utilization, cost, and revenue. Our early discovery questions included things like how are the rental facilities and fields being used, who are the largest customers, which locations you receive the most use, and importantly, what the impact on overtime costs were to the school district. Over the course of a year, we had 4 phases. The first phase was business discovery, really understanding the business drivers at Tacoma Public Schools, do industry and company analysis, define the project scope. We use tools like Microsoft Project, pestle analysis, Porter's value chain, SWOT analysis, and the like to understand the business, and tools like SQL Server to understand the data a bit. That was driven down into more detail in phase 2 as we did data exploration and diagnostic and descriptive analytics. We were creating data flow diagrams, data dictionaries, a data management plan. We were using tools such as SQL Server, Visual Studio Enterprise, DevOps, and using tools like Excel and Tableau to visualize the data that we were encountering. Phase 3, we moved into predictive analytics, doing some machine learning and forecasting, predictive visualizations. We used R to do some neural networks and regressions against the data, Azure Management, Machine Learning Studio, and introduced some Agile and Kanban methodologies into the project. Phase 4 was about cognitive analytics and the deployment of the project. So we looked at artificial intelligence and looked at different ways to deliver the information. We introduced new tools like Python, Power Apps, and Microsoft Cognitive Services in this phase. So next we'll do a demo, starting with Mario on some of the visualizations that the team produced.
Thank you, Joel. Thank you, Joel. Yes, I will discuss two dashboards that we created in Power BI to try to answer some of the questions posed by Joel, which were given by the client. We created several of these dashboards, but today we're going to focus on two particular ones. The first one, we're looking at administrative time by the school district in managing the rental program. In this first chart, you can see is by the fiscal year, and it's by the facility, by the time that is taken to manage the administration of this facility. So for the first year, the first couple of years, we see about 2,500 hours of administrative time dedicated to approving, scheduling staff, and entering the schedules into the system. This other visualization here is the total staff time by hours, by location. So what we see here is that high schools or schools with large athletic facilities are requiring the most administrative time, and those are areas where the school district may want to focus a resource to help them with that workload. Below, we see the types of organizations that schedule events at the schools and the amount of administrative time that they use. The group one here, which is internal to the school, is by far the biggest user of administrative time. Billing is done by a separate entity within the school district, so we have a separate visualization for them. Again, they're using 600 plus hours per year on the billing for these facilities. This second dashboard focuses on the number of requests and the organizations that are making these requests. Again, in this first visualization here, you can see that the group one is by far, again, the biggest user. And this visualization below shows the same groups and also the amount that is invoiced to those groups. As you can see, group one, because it's internal, they're utilizing the most amount of administrative time, yet they don't contribute in the form of revenue to the school district. And that causes the school district to look for revenue elsewhere, like in group 2 or 3, which are actually paying customers. These visualizations here also shows you the number of events by quarter. Quarter 1 and quarter 3 tend to be the quarters with the most amount of usage, so it's probably a good idea for the district to allocate more resources during that time and manage accordingly. This dashboard, as the other one, we have the ability to filter by date, so we can move. If we're looking at a time period that we want to look at, we can do that. Or if we want to look at a particular group, say we want to look at 3 and 4, we can do that, as well as by location if we want to look at a particular school. So with that, I'm going to pass it to Nima, who will be doing a demonstration on predictive analytics in R.
Thank you, Mario. I'll be talking about the predictive modeling that we have done in this project. So first thing was to decide on the variables to use for modeling, and we decided to predict event hours against variables like location, event date, organization type, number of events, and invoice total. So we ran a simple linear regression model, which would give an idea of how our variables are associated with each other. And the thing to look here in the output console is the adjusted R-square value. Usually above 50% is considered good, and we got 61.08%, which suggests that our model is really reliable. And again, a lower p-value helps to support the evidence. Next, we move to do a time series analysis in R to be able to forecast the facility usage in future. So this is a plot of event hour decomposed by monthly hours against time. Next, we did auto ARIMA model, and the thing to pay our attention is the AIC score, which is a suggestion of goodness of fit of the model. The lower the AIC score, the better it is. And we got a AIC score of 37.66, which suggests that the quality of our model is really good. Next, we went ahead and did a forecast plot. The one on the left side shows event hours against a time period. Auto ARIMA model does not factors in the seasonality component. So it did another plot, which is on the right side, which factors in the seasonality components and shows the curve. So what this clause suggests is enable to meet the demands in future. TPS need to maintain its current supply, which is the head count, to be able to function properly. Next, I will pass it on to Cooper to talk about more insightful findings we came across.
Thank you, Nima. I will be talking about Azure Machine Learning Studio. This is where we did some predictive analytics for the number of event hours that TPS is going to be incurring, as well as how much overtime they can be expecting from facility depending on the type of event. We used the neural network, which we found was the best model for us for this data. As you can see here, that when we go to visualize our results for our prediction on event hours, we can see that our coefficient of determination is a 0.85, which is really a fantastic coefficient of determination, and show that this was going to be the best model for our predictions. We also did the same sort of a training experiment for the overtime as well, and found that the neural net was the best one for the overtime. And as you saw before, we did a predictive experiment, which gives us an output in Excel. Through Excel, we can actually take some of our information, such as the location of Wilson High School, the Wilson Athletics Department, and whether or not they're going to be using the pool or the athletics facility, and determine how many hours do we expect each of these events to be. So we can see here that we predicted 2.6 hours if they're going to be using the pool, and 2.2 hours if they're going to be using the athletics or gym. And so using this, TPS can determine what staffing needs they're going to need. And when we're looking at these staffing needs, how much overtime is going to be incurred. Again, using a date, time, as well as the type of overtime, what is the reason, location, and type of location, such as the pool, theater, internals. We can determine how much hours do we predict are going to be needed for each of these events, and really predict what staffing needs they're going to need in the future. Moving forward, I'm going to be talking about our cognitive services. We found that Tacoma has 19.6% of people that speak a language other than English, and that TPS has a website and forms that are all in English, and may need some assistance to be able to provide more information to the neighboring cities and really the people that are going to be attending each of these schools. And so we suggested using the Microsoft Translator API, such as you can see here, to be able to convert this into a different language so that people can be able to understand and be able to fill out the forms more correctly. So as you can see here, you can have English, Russian, Chinese, or Spanish, in addition to many other languages. And you can even do text-to-speech or speech-to-text, whatever is going to make it easiest for you. So now that you've seen all of this, we can look in the key findings that we found. So from Mario and Nima's visualizations and through the predictive analytics, we can see from an administrative standpoint that the internal school activities utilize the most admin time at 47%. And the locations that are using the most administrative support are the high schools and athletic fields. For scheduling events, we can see that the majority of scheduled requests are for those internal groups, and that those numbers of requests and event hours remained high up until Q2 2020, when the COVID-19 impact occurred. Continuing with these key findings, we can see that based on the TPS facility history in Q1 and in Q1 prior to COVID-19, that TPS was on track to maintain their current usage, as well as seeing an increase in the potential bookings. This means that if they wanted to see what was going to happen in the future before we had this pandemic, they could use our predictive analytics to be able to see what are those future hours based on organizations, and what is the overtime usage, based on the reason and the location type as well. Some potential changes that we would like to see and have offered to them is the cognitive services, when they can implement a text translator for their public website and available forms so that they're more accessible to a larger part of the community. Thank you for attending, and we'd like to see you at our poster session from 1 to 2. Join us there and we can answer all of your questions. Thank you.